Hey there, everybody. This is Dr. V coming to you from the Chem Lab at Umpqua Community College. Welcome to Spring Term 2020, the term you'll be telling your grandchildren about someday. What I'm going to be doing today is walking you through the first lab, which is entitled Math and Measurements. There are several parts to this lab where we're going to get some examples of measuring different things using the metric system. And so I will show you those objects. I'll show you the measurements. You're going to have to record them yourself. I'm not going to tell you what the measurements are. For example, when we measure the distance of something or the length of something, you're going to have to read the measuring device and using your own visual acuities, you're going to then tell me, at least writing it out in the lab report, what that measurement is. So let's go ahead and get started with the first part of the lab. Okay, so for the first part of the lab, we are going to be measuring the length of two different objects. The first object that we're going to measure here is this little ballpoint pen. And I say little because it is shorter than most pens. And so we're going to measure that pen and figure out what the distance of that is. All right, so here is the pen, and as you can see, I've got a ruler down there, right, from the American Chemical Society. This side of the ruler has centimeters, so that's our metric side. If I were to flip that over and use the other side of the ruler, then you can see there that it has inches. But since we're in a science lab, we don't use inches, so we're going to flip that back over, right, and use the metric system. So I'm going to line this pen up so that one tip of it is even with the one end of the ruler, right? And then you can see as it goes down the ruler, right, there's the very end, right? So if you were to take a measurement of the distance of that pen, what would you call that length? Okay, so that was part A, question 1 of the lab, and now we're going to do part A, question 2. Determine the length of the long object. Here I have, you can see, a much longer object. This is one of the bars that we use in one of our ring stands. So you can see that's a little longer than the pen, and so to measure the length of that, I'm going to need a much larger metric stick. So I have my Metric in America ruler. If I place one end of that like so, right, line those up so the end of the stick is right even with the end of the ruler. And if we measure that down, right, youth of today will live and work with the metric system. Ha! If only. Learn more about it now. See, there you go. All right. So if I measure to the very end, right, you can see there, right, there's the distance. You can see the end of the stick. You can see the end of the ruler. What would you call that distance as far as if you had to measure that metal rod? Okay, for the next part of the lab, part A, number 3, determine the volume of liquid in the 10 mil graduated cylinder. So here we have a 10 mil graduated cylinder, and it's got some liquid in it, and you can see it's kind of a bluish liquid. I just added some food coloring to it. And so we're going to measure the volume of the liquid in that. What's important when we do liquids in containers is sometimes we can get a meniscus in a cylinder. And so a meniscus is when the water takes on kind of a U shape, right? If you look at the very top of the water there, if it focuses for me, right, you can see that the water there is kind of U-shaped at the top. And so when we read the volume of that, we want to measure the volume at the bottom of the meniscus. And so what we're going to do, right, is we're going to go ahead and see if we can figure out what that volume measurement might be, right? So again, there's the graduated cylinder in the water. And sometimes it helps, if you're able to, is to put some like white paper behind it. Sometimes that makes them a little easier to see. So again, if you were to measure the volume of liquid in that cylinder, what would you write down for that? The other one then is a part number 4, is in a 100 milliliter graduated cylinder, right? So now we've got a slightly larger graduated cylinder. We've got a different volume of water in that, and again, it's just water with green food coloring. So I'm going to ask you to write what you think the volume of the liquid in that graduated cylinder would be. All right, and I'm going to hold up a piece of paper behind it, right, so that you can see it a little more clearly. Okay, get that. Okay, great. Okay, moving on to part B, measurements and conversions. It asks us to determine the length, width, and depth of your classroom. Well, since you're not in this classroom, I'm going to have to do that for you. The depth, that would just be the height. And so I went ahead earlier and measured the height of this classroom, and I got 3.060 meters. Was my measurement for the depth or the height of this classroom. And so now I'm going to go ahead and measure the width in meters and the length in meters. Both of those measurements you'll then have to convert into inches. From inches you would then convert into feet. This one you'd convert into miles. And then the width, you're going to convert that into nanometers. And the length you're going to convert into gigameters, right? So we'll explain those in a little bit, but I'm going to go ahead and measure out the length and then the width of this room. All right, so now I've got the other end of this measuring tape attached to the other side of the room, and so it stretches across the floor out here to the doorway. Now when I get to the doorway, right, you can see there's my measurement of what the distance of this room or the length of this room would be. So you can see there on the measuring tape what you would write down as that possible measurement. So you can see there's this part here that says 9 meters. This would be 9 meters 30 centimeters. Here would be 9 meters and 40 centimeters, right? So you can approximate where you think that point is right there. That's the length of the room. And now I'm stretching out the tape to measure the width of the room as I'm backing into the door. All right, so you can see it's stretched out across the room, right? And now I want to see what my distance is, right, when I get to the very end of the room. So you can see that line there on the floor is kind of the edge of the room. That's where the doorway then meets with the prep room. So you can see there's the distance, right? And so we've got 13 meters 10 centimeters, we've got 13 meters 20 centimeters. Both of those measurements are visible, so we want to figure out where we want to estimate or approximate that measurement. Good. Okay, now we're moving on to part C, density of irregular shaped solids. The density of an object is the mass of the object divided by the volume of the object. And so if I have an object that's oddly shaped, and so in this case I've got 3 sticks of aluminum metal, right? So those sticks of aluminum metal, they have uneven edges, they're not perfect cylinders, there's some flaws in their shape. And so I can't mathematically determine the volume of those without the use of calculus, which we certainly don't want to do. So what I'm going to do is I'm going to measure the mass of these 3 cylinders of aluminum. Then I'm going to measure the volume of these 3 cylinders of aluminum. And if I take the mass of these cylinders, right, the mass of the aluminum divided by the volume of the aluminum, that will give me the density of the aluminum. So to measure them, I'm going to come over here to the balance, right? And I can see the balance that it's empty. All the doors are closed on it. And to make sure that it's reading 0, I would hit the T button to kind of tear it or re-zero it out. Then I'm going to place my 3 sticks of aluminum on there, right? And I'm going to see what weight I get, right? So in this case, I'm going to tell you that's 19.831 grams. Oh, 0.30 grams, right? So whatever the balance gives you, in this case, the balance is giving you 3 significant figures. All of those numbers that come after the decimal point are considered significant, so we would write those down. And so the mass of the 3 aluminum sticks is 19.830 grams. Okay. Now I have to measure the volume of the aluminum. And so how do we measure the volume of a solid like this, right? What I'm going to do is I'm going to come back to my graduated cylinder that has my green water in it, right? And I'm going to take my graduated cylinder with the green water in it, and I'm going to measure the volume of the water that's currently in that cylinder, right? So if I wanted to say what's the volume right now in that cylinder, right, what would we call that volume? Okay. So then if I take my 3 sticks of aluminum and I submerge those so that they're now under the level of the water, we can see that as I add the sticks of aluminum, right, so there's the sticks of aluminum, as I add them to the cylinder, now the volume of the liquid in the cylinder has increased, right? And the amount that the liquid has increased, we could say that that's the same as the volume of these sticks of aluminum. So I measured the mass of the aluminum, I measured the initial volume of water, and I measured the ending volume of water. Right, so the ending volume minus the starting volume will give me the volume of the water, or the volume of the sticks, and then the density of the sticks would be the mass divided by the volume. All right, so now we're going to move on and we're going to do part D. Can the density of an object change? We're going to use the balance to find the mass of the block. Right here I've got 2 different blocks of wood, and so we're going to pick one of the blocks, right, and then we're going to measure the mass of one of those blocks. Okay, so which one should I pick, the left or the right? Okay, I'll pick the right one. Okay, I'm going to take that over here to the balance, and I'm going to weigh that block of wood, and we can see that one block of wood, right, 33.301 grams. So one block of wood, 33.301. Okay, so I'm going to come back over here. One block, 33.301, right? So ideally, if I had been a good chemist, what I would do is I would take my paper with me over to the balance, so that as soon as I have the measurements, I can write that down, right? So now what I'm going to do is I'm going to measure the 2 blocks of wood, right? Now I've got 2 blocks of wood. I'm going to measure the mass of the 2 blocks of wood. Right, okay, and so the 2 blocks of wood, 73.148, right? That would be the total of the 2 blocks. Now, if I look at my chart, I have to measure the length of the 1 block, the width of the 1 block, and the height of the 1 block. Calculate its volume. Length times width times height would give me volume, and then the density would be the mass of the block divided by the volume of the block. The second 2 blocks stacked on top of each other, I would measure their length, their width, and their height, calculate their volume, and then their density. Okay? All right, I went ahead and did this for you. So the 1 block, we saw that it had a mass of 33.301 grams. Right, I've got to add my units because otherwise the numbers are meaningless. Grams. It has a length of 7.213 centimeters. It had a width of 7.520 centimeters. And it had a height of 1.302 centimeters. right? So you can calculate the volume. Mass divided by volume would give you density. The two blocks together, right? Two blocks together, focus, had a mass of 73.148 grams. The length was the same. The width was the same. The height of the two blocks, 3.230 centimeters. Right? So then again, calculate your volume and calculate your density. Right? And then we've got some questions that you can answer regarding that. And so the last part of the lab, part E, is measuring the density of water. It asks us to do that. It says the mass of an empty 50 milliliter graduated cylinder, right? So we've got an empty 50 milliliter graduated cylinder right there, right? And so we're going to mass that, which means we're going to weigh it on the balance. Then we're going to measure about 35 milliliters of water into the graduated cylinder and re-weigh the cylinder and the water together. Okay, so let's go ahead and do that. Okay, so here you can see here's the mass of my empty 50 milliliter graduated cylinder. I have 87.304 grams, right? And what's interesting, as you notice, is that the cylinder is just a tad taller than the glass box, and so I can't fully close this because, right, that gets in the way. So I have to leave that partially open when I'm weighing that cylinder. Now I'm going to add about 35 milliliters of water to the cylinder and we'll weigh it again. Okay, so now I've added approximately 35 milliliters of water to my cylinder, so I have a mass of 122.247 grams. Right, so the mass of the cylinder with the water minus the mass of the empty cylinder would give me the mass of the water. The volume of the water, well, to get the volume of the water, I have to take the reading off the graduated cylinder. Right, so if I get down here at eye level, right, that's kind of hard to see, so we'll put some paper behind it, and so maybe we could get a reading if my camera here focuses. Right, so you can see, okay, so there's 30, there's 35, right, and that looks, well, I will let you decide what you think that measurement would be, right? There's the 30 mark, right, so here's 30, there's 35, here's 40, 45, right, so what would we call that measurement there? Okay, the last thing I wanted to actually talk to you about was these things here. These are what are known as triple beam balances. One of the questions at the end of the lab asks you about the digital balance and then the triple beam balance. What we know about balances, right, again, we're measuring mass rather than weight. The mass of an object never changes. The weight of an object is dependent on the force of gravity. And a triple beam balance, the way this works, right, these are the different ways. So what I have here, right, is I have a pencil, right, that just happens to be what I have in my hand, but we could grab this, the tub of the Purell hand sanitizing wipes, right? So what we do is we look at the balance, right, and then we're going to take our object and we're going to place our object on the balance, and then we have to move these counterweights so that the line there then ends up at 0, right? So I might have added something that was a tad too heavy, right? And so let's see, so nope, 500 grams. Oh, okay, so there we go. So now we'll go back, right, until our little line goes below, or actually we want it to go above. Okay, so there's, right, 570, right? So we know it's more than 570. Then if I move it to 580, right, then it goes too far below. So the mass is somewhere between 570 and 580. So I'll move this back to 570, right? And then we take this last little bar here in the front, which is the ones place, right? And that we kind of move, right, until we get our little line. And we knew it was somewhere between 570, 580, right? And we're still above, so we're gonna go to 5. We're gonna move that to 6. Right now, let's try 7. Let's try 8. Oh, yeah, we're getting some possible movement there. Right, not quite yet. So we're getting close. We'll move that just a little bit at a time. Right, and then when those two lines are even, right, then that's when we've got our measurement, right? So I don't know what you would say about that, but to me that looks like that's just a tad below the line. So I'm going to move this last little gram one back just about a hair, right, which is an exact scientific amount. All right, so if I move that back, see where we level it out. All right, see now, what are we gonna get? Are we gonna stop? Well, if we stop there, that looks pretty close, right? Close enough for government work, as they would say. And so now that we've got those two lines equal, now we can read the weight on our balance. And so we've got 500 grams, 70 grams, and then we've got 8 point, right? So here's the 8.4, and maybe just a little bit past the 4, so we could call that 8.41. So 578.41 grams would be the mass of our container of PureWell wipes. Right, so now you can see how the triple beam balances work, and you can use that to answer the post-lab questions. All right, well, I hope you found that informative. I hope that was semi-entertaining for you. That's the lab. You'll now have about a week to complete that, so if you have any questions, go ahead and send me an email, send me well, not a text, but a message through Canvas or through Twitter. And I will see you again soon. Bye.